What if you could have your RAM bill without rewriting a single line of code? It's early 2026, and we're smack in the middle of a global memory squeeze. AI data centers are gobbling up every wafer of HBM3E, or high bandwidth memory, driving standard enterprise RAM prices to triple or more. We've officially slammed into the memory wall. While most IT directors are shelling out a massive density tax and watching their budgets evaporate, a revolutionary architecture has stepped in to rescue the data center. CXL, or Compute Express Link. CXL didn't just materialize. It's the result of collaborative genius. It kicked off in March 2019 when Intel donated its proprietary Compute Express Link tech to an open consortium. Now, CXL isn't just about memory. It also handles accelerators and other devices, but memory pooling is what's making the biggest impact right now. So that's where we're focusing here. In 2019, CXL 1.0 and 1.1 were essentially PCIe 5.0 with smarts, enabling a one-to-one CPU accelerator links. By 2020, CXL 2.0 brought switching, letting multiple servers tap a shared memory pool. Pioneers like Liquid rolled out the first composable racks here. From 2022 to 2024, CXL 3.0 and 3.1 doubled bandwidth to 64 gigatransfers per second and introduced fabric capabilities, shifting the conversation from cables to leaf and spine networks. And today, in 2026, CXL 4.0, released late last year and now running pilots, runs on PCIe 7.0 at a blistering 128 gigatransfers per second. It introduces bundled ports for flexible scaling and advanced RAS, or reliability, availability, and serviceability. Features like error correction for AI reliability. From a niche Intel project, CXL has exploded into a universal standard, backed by over 250 consortium members, including AMD, NVIDIA, Samsung, Marvel through their 2026 XCon acquisition, SK Hynix leading CXL memory for AI, and every major hyperscaler. Market projections? CXL revenues could hit $3.4 billion by 2028. That's 400% growth in just 2 years. But history isn't just dates. It's rooted in physics. Virtual machines are sneaky liars. We over-provision CPUs easily because they're temporal resources, time-based. But RAM? It's spatial, like parking spots. No time slicing here, so we fat provision memory just in case. You run out, it swaps to SSD, slamming 1,000 times performance hit. CXL acts as a nearby parking garage, bridging the gap with 150 to 300 nanoseconds of additional latency on top of the local DRAM's roughly 100 nanoseconds. So, total FAR memory latency runs 250 to 400 nanoseconds. Still orders of magnitude better than SSD swap, and mitigated by tiering as near memory between local DRAM and storage. For 15 years, we've cheated physics with memory ballooning via VMware's VMM Cuddle driver, inflating inside the guest OS to reclaim RAM. But what about in 2026? Modern AI and databases constantly sweep memory. If you balloon, you could spark a swap death spiral. Ballooning's a relic from 2010. CXL delivers true physical resource pooling. No OS tricks, just more lanes. Plus, CXL 4.0 amps up security with fabric-level encryption and integrity checks, vital for multi-tenant AI clouds and handling sensitive data. But what about the drawbacks? Higher latency than direct DRAM can saturate bandwidth in ultra-low latency apps. But for AI inference, industry reports show utilization improvements of 20 to 40%. Early adopters note vendor interoperability hiccups, but standards are solidifying. Let's talk real numbers. Here's the math that forces your hand. Take AMD's 192-core Turin, like the EPYC 9965. Most workloads need around 8 gigabytes of RAM per core. For a 192-core CPU, that's 1.5 terabytes total. Now here's the problem. If you tried to use 64 gigabyte DIMMs, you'd need 24 memory channels to hit that capacity. But these CPUs only have 12 channels. So you're forced into 128 gigabyte DIMMs, or even 256, just to reach the density you need. And that's where the premium kicks in. 64 gigabyte sticks fluctuate around $700 to $1,200. That's $11 to $19 per gigabyte. But 128 gigabyte sticks, they explode to $3,200 to $4,600 with premiums driven by shortages. That's $25 to $36 per gigabyte, more than double. And 256 gigabyte sticks hit $5,500 and up, over $21 per gigabyte. But you're forced into buying them for density. Now here's the CXL hack. Stick to the cheaper 64 gigabyte locally, pull the rest. Your local DRAM runs $11 to $19 per gigabyte, while pooled CXL memory, again, even with the fabric overhead, comes in at around $15 to $20 per gigabyte, but with 60 to 80% utilization instead of the typical 40%. The effective cost per usable gigabyte, what does that look like? Traditional approach, $60 to $90 per usable gigabyte at 40% utilization. Again, industry standard. CXL approach, $20 to $30 per usable gigabyte at 70% utilization. That's where you reach your 40 to 50% total cost of ownership savings. You're paying for what you actually use. But here's the key. You get both benefits at once. Cheaper RAM per gigabyte and better utilization through pooling. And they compound each other. That's the arbitrage. So how does this actually work? Pioneers like Liquid's Matrix software orchestrate the fabric invisibly. Assign 96 gigabytes of CXL memory, the OS sees it as local DRAM. No drivers needed, invisible to the server. It's like a stealth hardware upgrade. And it's intelligent at the fabric. Liquid tracks usage. If a VM only uses 60 gigabytes, the rest stays pooled. This invisible composability brings cloud agility without code tweaks. But Liquid's not alone. Competitors like Astera Labs with CXL retimers and switches, Compal with liquid-cooled CXL racks for AI, and XCon under Marvel with lossless fabrics for trillion-parameter models are now in the mix. Compare to AMD's proprietary Infinity Fabric or NVIDIA's NVLink, faster but ecosystem locked. CXL's OpenEdge, mixed vendors seamlessly like AMD CPUs with Samsung expanders. Now, as normal, hyperscalers are leading the charge. Microsoft Azure's Pond research highlighted a critical insight. Stranded memory often results from core-heavy, memory-light virtual machines being co-located with memory-heavy workloads. CXL fixes this fundamental mismatch, not just the cost. Azure's 2025 CXL previews with Intel and SAP for dynamic M-series virtual machines proves the concept, with other major cloud providers piloting CXL for AI cost optimization. But here's the kicker. Don't expect those savings to show up on your bill. While hyperscalers cite the global memory squeeze to justify raising your instance prices by 10%, they're using CXL to bypass those costs entirely. They're lowering their floor and raising your ceiling, all at the same time. For AI, CXL is a game changer. Offload KV cache from pricey GPUs to pooled RAM, boosting inference by 2 times, and trimming power by 15 to 20%. It enables message-free node communications for high-performance computing research, cutting multi-node overhead. But not all apps win equally. In-memory databases like SQL and SAP HANA face high RAM over-provisioning and swap spirals. CXL brings pooled memory for dynamic allocation, no ballooning needed, 30 to 50% TCO reduction, and 2 times query speed. Best for medium to large setups with 5 or more servers. Key value stores like Redis are memory hogs for caching with high density attacks on dense cores. CXL offloads caches to the tier with seamless expansion, 40% lower RAM cost, and reduced latency hits. Fits any scale, especially cloud. AI training and inference like LLMs deal with KV cache explosion and GPU memory bottlenecks. CXL shares memory across nodes and frees GPUs for compute, 20 to 40% efficiency gain and 15% power savings, best for hyperscale or those enterprises with 20 or more racks. Virtualized workloads like VMware virtual machines suffer ballooning failures in modern apps. CXL provides physical pooling, replacing tricks with hot plug support, up to 50% utilization boost, ideal for enterprise data centers, especially if the infrastructure team may not know exactly what the application is doing. High-performance computing simulations fight underutilized memory in shared clusters. CXL enables fabric-level sharing and message-free communication, 25 to 35% resource savings, perfect for university and research. CXL is a powerhouse, not a panacea. Latency adds 150 to 250 nanoseconds, a compromise for scalability. What's the overhead look like? Liquid's HBA, around $3,900. A switch, $15,000. A chassis, $23,000. Under 10 servers, cost each savings. And there's a redundancy trade-off. The more servers sharing pooled memory, the larger your failure domain. One fabric issue can impact multiple hosts. You'll need a robust failover strategy. At scale, the server-in-a-box era ends. Your choice? Build fabrics or pay up. So where does CXL stand in early 2026? The honest answer? It's an active deployment for niche, high-value use cases, but the memory supply crunch is about to change everything. Right now, CXL is production-ready primarily in 3 domains: hyperscale cloud providers running AI infrastructure, high-performance computing labs with extreme memory demands, and large financial services firms with massive in-memory databases. Again, like SAP HANA. These organizations have the scale, technical depth, and pain points that justify the custom integration work. The Type 3 memory expansion market is hitting 1.8 to 2.5 billion in 2026, driven almost entirely by these early adopters. What about for standard enterprise deployments? Well, we're in a transition phase. Current generation server platforms from major vendors include CXL support at the silicon level. Think Intel's 4th and 5th gen Xeons or AMD's EPYC 4th and 5th gens, but most enterprise server offerings don't yet ship with CXL as a standard turnkey feature. You can get it, but it often requires working with a specialist integrator, specifying custom configurations, or partnering closely with your infrastructure vendor. Here's what's changing the calculus. The memory crisis isn't easing. With DRAM shortages projected through 2027 and prices spiking 300+% in some segments, the economic pressure is forcing an acceleration. Major server vendors are fast-tracking CXL integration into their 2027 and 2028 roadmaps, not as a premium feature for niche workloads, but as a standard answer to the memory cost problem. What does this mean for you? If you're planning an infrastructure refresh in 2026, insisting on CXL-capable platforms is the smart future-proofing, even if you don't deploy pooling immediately. By late 2027 and into 2028, expect CXL to transition from a specialist deployment to an enterprise standard option as vendors productize turnkey solutions and the ecosystem matures. The memory squeeze is the catalyst. CXL was always technically sound, but economics are now forcing adoption. Enterprises that deploy in 2026 are early adopters with high pain thresholds. Those deploying in 2027 or 2028 will find a much smoother path, but they will also be paying those inflated memory prices for another 12 to 24 months. Take a 30 server rack of AMD's Turins, these 192 core processors. Traditionally, outfitting each with 1.5 terabytes via 128 gigabyte sticks runs around $55,000 or more per server. That's $37 per gigabyte of installed RAM, but only $92 per usable gigabyte at typical 40% utilization, totaling over $1.65 million in RAM alone. With CXL equipped locally with cheaper 64 gigabyte modules, around $1,200 each, that's $14,400 to $28,800 per server, depending on the specific config. Then pool the rest via shared fabric, factoring in about $3,900 for the HBA per server. That's $117,000 total, a $15,000 switch, a $23,000 chassis that is shared across the rack. Effective cost? $25 per usable gigabyte at 70% utilization. What's the net RAM savings? $26,000 to $40,000 per server, or $780,000 to $1.2 million for this 30 server rack, offsetting overhead for a 40 to 50% TCO cut. Aligning with industry projections, plus 30% better utilization, reducing idle memory from 60%. At this scale, you're not just experimenting, you're optimizing. Hard. So, ready to get started? Here's what you need. Check your CPU. Intel 4th or 5th gen, AMD EPYC 4th or 5th gen required. The OS, Linux 6.8 or VMware 8 or higher. The hardware, grab a CXL-ready HBA or host bus adapter card with a fabric switch like Liquid's FX series or Astera alternatives. The strategy, target memory hog workloads like in-memory databases, SAP HANA, or even LLM inference. You can offload KV cache to pooled RAM for GPU freedom. Looking ahead, CXL 5.0 in 2027 to 2028 might add optical leaks for rack scale zero latency. More importantly, the next wave of server platforms launching in 27 and 28 will bring CXL from optional to standard, driven by relentless memory cost pressure. Environmentally, it's a win for sustainable scaling. So here's the bottom line. When it comes down to it, CXL is a real, deployable technology for production today for high-value use cases, and the memory crisis is accelerating its path to mainstream adoption. If you're running hyperscale infrastructure, AI workloads, or massive databases, CXL delivers proven 40 to 50% TCO savings right now, but expect integration effort. For the standard enterprise IT, the timeline is clear. 2026 is the year for early adopters with severe memory pain and technical capability. 2027 and 2028 is when CXL becomes a standard checkbox on your server RFP, as vendors productize solutions and the ecosystem matures. So here's your decision. Deploy CXL in 2026 as an early adopter and start saving immediately, or wait for turnkey solutions coming soon and pay for inflated memory prices for another 18 months. Either way, CXL is coming to your data center. The only question is when. I'm Dan, and I'll catch you in the next one.